Hello folks, well today we've got this DNT Supertuned version of the M40. So what this is all about, it isn't that they did some good twiddling, it is that part of the receiver was rebuilt by Cleartone. Now Cleartone of course do business two-way radio and always did do business two-way radio, but they must have felt that it was a good idea to come up with a solution to the problem with the DNT M40, is that it was a bleed over box. Now, I live in the middle of nowhere, as you know, and it really doesn't matter what's a bleed-over box and what isn't, because I don't have any neighbours for half a mile. The nearest town is 7.7 miles away, nearest city is 35 miles away, so it isn't a problem. But in people in locations where there's a lot of CB activity in some cities and big towns, then it can be a problem. It certainly was back in day one in 1981 when every third house had a CB aerial. So these went to Cleartone and they did some improvements to the receiver, including a crystal filter and some dual gate MOSFETs or something. But the problem is I have no documentation of what they did. So if there was receive problems on a super tuned version, there's nothing I can do about it. So this is very nice condition. The customer's put a power lead on it, and I think he says it whistles. He sent in a DNT original mic which needs wiring. He sent a plug for me to put on. But in the meantime, we'll run with standard replacement mic of ours with a plug on the end for the 5-pin DIN. These are gold-plated plugs. Right, where are we? We need to connect this up. Right, power on. Channel 20. These have always suffered from dry joints right from day one. I think these must have had the highest return rate ever. I don't think you need a because it's relay operated, I don't think you need a mic for receive. Sounds a bit awful, but anyway, there you go. Right, so let's just run through it. So it's the 6th of November 25, DNT M40 Supertuned. There's a big difference. I wouldn't recommend people buy these either unless they're working. Serial number 05500. And customer details, just for our reference. No transmit. No transmit on anything. They're a general purpose synthesizer, which is another problem. I don't expect the face out loops running. Just hope it hasn't been messed with. That's something that can happen. One of these that can get turned into 10 meters quite easily, with it being a general purpose synthesizer from Motorola. But that end of it tends to be reliable. Just get my signal generator somewhere there, put picture in picture on, and then you can see me with wherever the mice have put the cameras to overnight. I can reset the positions of all these cameras every day and they'll move overnight. It's trouble when you live in the country. Okay, so we're on We were on 27799125. I'm going to put a whacking great big signal on. There's our whacking great big signal. At least the squelch works. I think the IF's working because I can make it block. Right, we'll better open it up. All the lids. It's not that screwdriver for these. I think they're M2.5s if I remember. But sometimes they're going to be altered, aren't they? Yeah, they've been re-threaded for M3, so fair enough. We'll go back to the other screwdriver. Put my soldering iron on because it's a soldered on speaker. So a double-sided printed circuit board, it's not plated through like a modern fiberglass one would be, because it's SRBP, and they really suffer from dry joints, and as I said, they did from day one. So a lot of the connections depend on both sides of a component being soldered, or shall I say that another way, the lead from one component being soldered on both sides of the board. So there are no plated through holes, it's just a matter of either component leads or just tin copper wire going from one side to the other and being soldered, and it is a problem, and it always was. At least it... Oh, good grief, we've got chips in sockets. No, you can't do that. Oh dear. They don't not put chips in sockets to save 10 pence. That's another problem. Oh dear. Well, I think this one's going to be going back. Can't think we're going to be able to proceed. That is the most bonkers thing I've ever seen. Well, it isn't. I keep seeing bonkers things, don't I? If I've got a scrap chassis to show you, I might have to go to another workshop as to why you can't do this. If you study electronics, the synthesizer can't go in a socket, and really the MC3357, you're hard pushed to be able to get that to go in a socket, because you're just introducing all kinds of snags. You probably get away with the logic chip there. It's an extension speaker. I won't put the instruments in, I'll put the one on the wall in. I don't want volts to go into the instruments. I've now got no audio on receive. Why is that? So in taking the lid off, we now no longer have audio on receive. We do now. It's not going to be a lock voltage, so it can't go into transmit until it sees a lock voltage. So we don't see the TX light coming on unless I'm not plugged in right. It will not click and go into TX until the phase lock loop is in lock. So I'll tell you what, I'll have a look around for dry joints for a start, but the thing is, if we get this working, it's going to be a bit weird because of the sockets. Okay, so the next day I put some real time into this, and we've actually got the synthesizer running. With this being in sockets, which I say is far from ideal because it does cause snags, I was able to change the synthesizer chip and it made no difference. So of course I've gone through for dry joints, there's plenty of those. There's kind of a test point for VCO, which is that junction of resistor 32, but I don't know what the procedure is. I've set it for what you'd expect to be something sensible on channel 20, and I can always fiddle around with it at the band edges to make sure it's in lock. Same applies with transmit, because you've got this 4011 CMOS logic gate controlling the transmit relay. Unless the thing's in lock, it isn't going to let you transmit. So I looked at the circuit, and when we went into transmit, we'd got pin 1 and 2 where, I mean, I don't know what the truth table is for what this is, and I don't want to see M40s anyway, as I've said before. Still getting them come in. You know, there's going to come to a time when, unless it's just a retune and test, they're going to go back, because there's nothing worse than spending all this time and then you're charging the customer and they get it back and it doesn't work because there's more dry joints. They were ropey when they were new. So I've set the 10.24 between pin 3 and pin 4. That is spot on 10.24 with the frequency counter. I've shown you that many times before, I don't need to go through that again. Pin 3 and 4, there's the crystal, there's the trimmer. So I came to the conclusion that around here, the logic gates, you've got the 4 sections to the logic gate on the 4011, and I came to the conclusion that when I went into transmit, nothing was happening. We got it on pin 6, nothing was kind of coming down here, nothing was happening around the transistor. So I resoldered everything around there. Oh, what I didn't tell you in the meantime is I swapped the logic gate, and now it works. So it was a brand new. I bet CPC don't sell those anymore. Now these are static sensitive, so you've got to be very careful. It's not something to run up and rub up and down your nylon tracksuit. So you can hear we've got receive. Now I've not fiddled with anything other than these to get myself into transmit. So I've had to fiddle with that because it's been fiddled with previously, which is the VCO for receive, and of course I've had to fiddle with the transmit VCO to actually get it to go into transmit. So you can see we've now got transmit. I'm on low power. We could go to high power for giggles, and it's doing absolutely 3.6 watts. So, you know, fine. So I think we'll, having fixed that, I'd like to wrap this up today, because it's Sunday. I shouldn't be doing anything. I've done my church services, but I've got a base station to do tomorrow, and it's difficult to get a base station done in one whole in a whole day anyway. So no PLL operation. 4011 replaced. Dry joints. So we've gone from dead set other than lighting up to transmit and receive, but the two didn't come in one chunk. Right, so with our standard replacement mic we will go through transmit. I think we've got all this stuff right, so I may have to touch up the VCO. Wouldn't it have been nice if they'd have supplied me with a service manual when I asked them in 1982? But it was, no, don't do them. So VCO, well, that's the wrong tool. Transmit. These early ones I'm doing for maximum power consumption because I can't see on the meter any change. So I've got 1.26 amps. I'll do the same with this one. That's going down. That's our peak, 1.279 amps. That's receive VCO. We'll now move on to this one, transmit. Should start seeing it on the meter. Yeah, that's fine. We can peak that on the meter. We can peak that on the meter. We're at 4 watts. Four watts. 4 watts. As it's warmed up, it's 3.99 something, you know. But that's 4 watts. Okay, we better do the frequency. So the first thing is set the 10.24, which I've done, and that's done with the frequency counter monitoring between pins 3 and 4 of the IC, or one of those pins in ground is what we're trying to do. But then you've got these mixer crystals. The transmit one is here, the receive one is here. So we've got to now set the frequency if we can. Here's the thing, if the crystals are dropped because they're 40 years old, this can be some jiggery-pokery. But we've got 10.24. Sometimes we don't get 10.24. It's 10.238 or something like that. We've got to do the best we can. The trouble is, if you get the receive wrong, the receiver's going to be off balance. Is the phrase non-sinusoidal? Right. So now what I want to do, I'll just switch some other gear on as we progress through this. I've even switched a deviation meter on. What we're going to do I can't put a before down because it was nil. I'll come back to these figures shortly. Let's look at low power. It's 260 milliwatts. So we'll do low power. Preset is here. That's dirty. You know how you get graffiti on the back of vans, especially white vans, and you get, I was thinking about dirty, you know, and it says, this van is dirty, etc, 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 something rude about your wife. Well, I saw a foreign van, and it said something in a foreign language, and I've no doubt it was just as rude as what you get with UK graffiti. I did find that amusing. But as somebody who enjoys Viz comic, you obviously have that kind of sense of humour. We're definitely doing 4 watts. We're definitely doing 400 milliwatts. So I'll put 4 watts there. We'll come back to the other channels because it may not be in lock. So it's 1.26. Meter on the front. It's I'll put high because it's not right. It is too high. And then somewhere we've got meter adjust. It's the one nearest me. I picked up the wrong mic. And that's now in the centre of the strawberry patch. Mind you, I can hear it receiving, but considering I've got a whacking great big S900 microvolt signal on it, I hope it's nice and sensitive. These don't have PA. Frequency, I need to do the frequency because at the moment it's going to be, I haven't adjusted anything, but at the moment it's 2779,102. Let's show you that. Or did it say 202? Might have been busy. I've stuck some more poison in the loft. 2779,202. 2779,202. That would be too high to... People would start noticing it was off frequency. Transmit, just look at the notes. I think it's the one on the right. It is. So trimmer on the right, we'll see if we can get that on frequency. We should be able to, because it's high. It's when they're too low you've got a problem. There we go. So I'll leave it very slightly high because they drop with age. See if there's any deviation. We have to reset all of these cameras, aren't they? Wallow, 1212, wallow, wallow. We've got, it says 2.5 on this test set. I'll come back to that later on because I only put the other test set on 10 minutes ago. And although it might be okay, why bother? So, that's our transmit. I just tentatively go to channel 40 and see if it transmits. Just put you on the main meter, you are on the main meter. And it's 3.8 watts on channel 40. And we've got no problem with lock. and we've got, oh, there's a bit of a diphthong there. So what is it? This is where we're going to spend ages untuning it. So what channel does it start diphthonging on? About channel 4. Yeah, lucky to get one channel on these, let alone 40. Just reset those. So I'll have to come back to this now when it's cooled down, because at the moment we've dropped to about 3.6 watts, which is not surprising because it's obviously warmed up. So we'll come back to that, but that tiny adjustment, but it's what is it? What's causing the problem? And you've got to start untuning things. You think, well, no, I've just done it. Right, receive. I think we better start by putting it on frequency. In actual fact, that's 1 microvolt. It's receiving very well. Now the Supertuned version is very sensitive. It's just the trouble is if you've got a fault on the receive, what do I do? Because it's not as in the documentation. So we've got more scrap bin Supertuned ones than any other type. So I need to plug in my secondary signal generator, my cheap Chinese one, which we're just using as a marker oscillator, as it's called. So what I want is a reasonable signal, and I want no tone from the signal generator, and volume up very high. So we'll switch this on, and we want this on 10.695. There it is. Straight away we need to nullify that musical note. 10.695. Just make sure we're on frequency with the signal generator. No, we're not. Lucky I checked. So we want 2779125 on here. That'll do, slightly high. And there we are, on frequency. Okay, put the tone back on. And I'm now happy to go from the speaker on the wall to the test equipment speaker. So we can look at cyanide and all that. Right, let's get ourselves somewhere. Let's get over to the cyanide meter. .74. .54. I'm sure these are capable of better than this. And oh dear, it can't do 20. Squelch. I seem to remember it's wishy-washy on these. Three is our maximum. And the sensitivity of the squelch. Is a very good 0.51. The S meter is reading stupidly generous at 16 microvolts. Right, we want the detector, and we'll get that set and see whether we can get an improvement. So we'll go over to the oscilloscope. We'll put enough volume on for a sensible trace. That doesn't look very nice, but then these sets aren't very nice. Another batch of stuff from trucking and farming. As promised, there's a Team 8080 channel base station. We've done this channel all these years, never found one which I could get to work, and then an Immaculate comes in from there. And he's taken his Harrier CBX out of his glass display cabinet at home for service. What a man. Right. Detector. I think we've got an IF out, so I can't really set the peak. So what I'm going to have to do is see if we can set the IF. Because that gets mistaken for the detector, chances are that's the biggest culprit. Yeah, it looks like it. I'll see if I can see that on the meter. Not really. See if we can put a bigger signal on and see it on the meter. I think we're about there with that. I think we ought to look at that receive in the same way. That looks spot on. We've found something that's not been fiddled with. Yeah, that's spot on. That really leaves us with the front end. drop the signal. And turn the squelch down. That was spot on. And that was spot on. So those three were spot on. I'll have to check that the VCO's locked on all 40 channels. Instead of dialing the signal generator up and down, which is a pain in the what's it, I'll just get my walkie-talkie and make sure it works on 1 and 40. So still not happy yet with that. Not a lot I can do. It looks better. I think we've got that one right. Well, according to the cyanide meter, that's right. And that does tally with what the meter on the front says. Let's go back to 100 microvolts. It's about there. It's not nice. I don't know whether we've got filters, whether the fact that's in a socket should never be in a socket, whether the crystal's slightly low, you know, there's all kinds of things. The point is it does work, and it won't sound as crap as you might think. Right. So we should now be able to achieve, that's not the right camera. We should now be able to achieve 20 dB, I think. It's not the purest sine wave, but let's have a look what we've got. I'll just check we're in DX and not local, because you've got DX local RF gain switch. So I think we can agree that's spot on 12 dB. We're probably going to have an inferior reading. We haven't. 0.7, and it's only noise this because we can hear this right down to, I can hear this right down to 0.3 microvolts. 10 dB. 0.5. But have we got anything near 20? It's not going to do 20. To do 18 at 3. So if we wanted it to improve, I'd want the socket removing from that, I'd want the crystal changing, I want both those filters changing, and all the capacitors in the audio section. But it ain't going to happen because the set does work, and it will probably carry on doing so. Right, meter on the front is now banging across. It was banging across anyway, wasn't it? S9 is there. It is lit up, isn't it? Yeah, it is lit up. So we've done that. It's 100 microvolts. The switches all work. And the squelch, I don't think we've got any adjustments for. You get what you're given on this. No, it doesn't have those. So let's see what we've got on the squelch. I'll turn the squelch to full. It's still 3 microvolts. Let's see what the sensitivity is like. It's 0.3, isn't it? I'll tell you what, let's go give it. It came in at 0.3, and it went up against 0.39. So this is never any good in a city full of users, because you're not ever going to be able to squelch out the noise. I've said that right from the word go, though. It's not this particular sample. They're all a bit too sensitive on the squelch. Not enough range of squelch. We'll do the deviation, and I'll fetch my walkie-talkie and make sure that it's receiving on the band edges, and then we'll just check the power on channel 1. I honestly thought this was one we were going to have to send back, but it has had. This is session number 3, you know, and we can't afford to spend this kind of time on this kind of radio, because we're only going to be charging him for the level 2 service and not level 3. Oh, look, he's spot on. Absolutely spot on. Good. Well, the Phantom Fiddler didn't Phantom Fiddle with that. I've cleaned the board underneath with isopropyl. All I need to do is fetch the walkie-talkie. Okay, so we'll just make sure on channel 20. I'll switch this to low power. It is on low power. Testing 1, 2. I'll tell you what, we'll go to the speaker on the wall rather than one right in front of me connected to all the test gear. Testing 1, 2, testing 1, 2, 1, 2. Wow, low 1, 2. Alright, let's go to channel 40. Testing 1, 2, testing 1, 2. Not even on an aerial. And channel 1. Testing 1, 2, testing 1, 2. Well, it sounds pretty awful and distorted, so we may not be out of the woods yet. So I really don't want to start changing all this. Let's see if we can hear anybody on it by plugging in the aerial. But that's why we do on the air tests, because you think, oh, that's spot on the bench, and it certainly isn't when you get it on the air. One and a Roger. We're all watching Songs of Praise on television with it being Sunday. Well, there we go. We just need to put the test set back on and check the power on channel 1. So I'll launch this video, and if the turns, when we do the on the air test in a couple of days' time, because I'm stacking them at the moment, if there is a snag, we'll do a revisited. Right, let's have a look at the test set. Go into camera 1 and move it around, because the mice don't seem to be very good at resetting them. It is 4 watts. There we go. I'll solder the speaker back on. I'll just put a couple of screws in it for now. I'd sometimes love to know the backstories on some of these sets, you know. Why was everything put in sockets? So the thing here is, you know, you can do that with the 4011, but you can't do it with the synthesizer, and you can't do it with the MC3357. There you go. I wouldn't want this in a damp environment like a car, with it being in sockets, and it's not like they're even gold-plated ones. There we go. Let's go back onto the roof aerial. See whether this. Yep, the internal speaker actually works. Let's put it back on 19. It is on 19. Let's put the aerial back in. Aerial's across my knee. And then it fell off my knee. Just nice if we could hear somebody on it. And although you can have iffy capacitors, especially in transmitted audio around those 2 transistors in the microphone, speech processing and preamp, which is here. You've got this 1 microfarad there, you've got 1 microfarad there. We've had that 2.2 play up. Let's get that where you can actually see it. So your microphone goes in there, deviation control there, so you've got 2 transistors and the capacitor and resistors and things doing the speech processing here. There's no chips, so there isn't, you know, I've got no audio, the speech chip has got. There isn't one, it doesn't go through the audio amplifier, so it's just those capacitors, and we haven't had that on this one, which is good. We've got a music player. Fancy hearing a music player on 19. Christmas is early, isn't it? And a K-bleep as well. It's not the wrong screw, it's the threads damaged. Right, well, we'll leave it at that, and we could talk to them about bandwidth and why music playing over a narrow band like that doesn't work. Thanks for watching the not so easy DNT M40 from 1981.